Hey guys, so today's screencast is going to explore air pollution. So far we've been really looking at sort of air pollution from a global perspective as we've examined global climate change, the greenhouse effect, as well as ozone and stratospheric ozone depletion. So I thought we'd sort of focus our attention more on localized and regional air pollution today. But first, real quick, let's sort of just define what pollution is. It's really the presence of chemicals in our atmosphere at a sufficient enough concentration that can really cause harm to any living thing or ecosystem for that matter, as well as affect global climate. And we can actually break our pollutants into two broad categories based on where they come from, right? We have both natural sources and anthropogenic sources or human-derived sources. So geologically, air pollution is not new. Natural sources, of course, include volcanic eruptions and forest fires. But of course, since the Industrial Revolution, certainly air pollution levels have increased exponentially with the advent of technological advances as well as our use of non-renewable energy resources. So once in the atmosphere, these pollutants can be broken down into two broad categories. One category is what we call primary pollutants, and primary pollutants are emitted directly from their source into the atmosphere. So these include carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxides and nitrogen dioxide, as well as nitrous oxide. VOCs are also considered a primary pollutant, such as methane or other hydrocarbons. So these are primary pollutants that can, by themselves, cause significant harm. However, oftentimes these primary pollutants do in fact mingle with each other, and not only with each other, but the other natural constituents of the atmosphere itself. And when they mingle, they can form new pollutants, and these new pollutants are then of course referred to as secondary pollutants. So oftentimes, for example, you can have a primary pollutant like sulfur dioxide, and when that reacts with water vapor, this is a precursor to acid rain, it will then form a secondary pollutant like sulfuric acid, right? Nitrogen oxides, for example, also react with VOCs as well as sunlight in photochemical reactions to produce secondary pollutants like ozone, right? So I think it would be really helpful for you to study this slide and certainly classify these various types of pollutants based on whether or not they're primary or secondary. So as a result of significant grassroots pressure in the 1960s, sort of at the dawn of the environmental movement, the governments, both federal and state, have made attempts to improve our air quality. And really, since that time, air quality has improved significantly as we've developed a variety of output control devices and other regulations. It really sort of kicked off in 1963 with the passage of the Clean Air Act. However, in 1963, it was the states that were charged with setting standards and identifying specific pollutants to manage and regulate. And this, had limited effectiveness, I suppose. And you can imagine why, right? Each state sort of having separate policies, separate standards, that sort of, results in inconsistencies. And you can imagine certain states which are heavy in certain industries are probably going to have more lax regulations with regards to certain emissions compared to other states. And therefore, it created lots of tension and conflict between the states. Because as we know, pollution, doesn't really know state boundaries. So it's not just a localized event, but it can travel several hundred miles and affect large regions. So as a result, they realized, the effectiveness of this policy was severely limited. So in 1970, they amended the Clean Air Act, and they actually charged the federal government with overseeing air quality issues in the United States. And of course, specifically, it was mandated that the EPA was to identify and set clean air standards. And the first thing they did was to come up with a list of what we call criteria air pollutants. And these were the pollutants that they were going to observe, monitor, and regulate. So these 6 pollutants, a good way to remember these criteria air pollutants is to think of the acronym nose clip. You know, right? It gets a little stinky when you give off certain gases, and you don't want to inhale them, so you place a nose clip on your nose. And of course, nose clip stands for nitrogen dioxide, ozone, sulfur dioxide, carbon monoxide, lead, and suspended particulate matter. So you have a list of these that you picked up in class. They are called the 6 Criterion Air Pollutants. And on that list, you have 4 columns. One column is the pollutant itself. The second column is the source, so where does it come from? The third column are the health effects. And the fourth column are the environmental effects. Study this well. This is really important, and you can start to organize your thinking around this chart. Nitrogen dioxide is what is known as a primary pollutant. It's given off from the combustion of fossil fuels, specifically coal, as well as from automobiles. Nitrogen dioxide is a precursor to a variety of secondary pollutants, including nitric acid, which contributes to acid deposition, and it is also a precursor to the formation of photochemical smog as it reacts with VOCs, sunlight, to produce ozone in the troposphere. Alone, nitrogen oxide can actually have significant health effects in terms of human health and our respiratory system. Nitrogen dioxide as well reduces visibility and can damage vegetation. Moving on, nitrogen dioxide again was a primary pollutant, while ozone is considered a secondary pollutant because it's the result of photochemical reactions in our troposphere. It is created when nitrogen dioxide reacts with VOCs and sunlight, and in our troposphere, ozone is a very bad thing, as we know, again affecting the human respiratory system, increasing rates of asthma, bronchitis, heart disease, and it also suppresses our immune system as well. There's many environmental effects aside from reduced visibility. It also destroys vegetation as well. Sulfur dioxide is another primary pollutant. It is another precursor, just like nitrogen dioxide. It is a precursor to acid rain, as sulfur dioxide reacts with water vapor to form sulfuric acid, which is a secondary pollutant that reduces the pH of our streams and soils, of course. Alone itself, it is also has large effects on the respiratory system and can cause lung damage, eye irritation, and burning of skin in certain circumstances. Carbon monoxide is another primary pollutant. It's the result of the incomplete combustion of any fossil fuel, and this also has catastrophic effects on human health. And it's more small-scale versions with lower concentrations. It can cause dizziness and fatigue, but it can get to the point where it can actually kill a person, of course. Carbon monoxide has sort of an affinity for hemoglobin, and it binds to hemoglobin and prevents it from transporting oxygen to our cells. Next on the list is lead. This is, of course, a metallic element. It is released from the burning of fossil fuels. It's found in gasoline. The United States phased it out years ago. However, many developing countries still use leaded gasoline. It's also released from paint. We've also phased out lead-based paint in the United States, but any homes built in the early 1970s or before still contain it. And that's an issue, right? Because if children consume this lead-based paint, it can have all sorts of harmful effects. It is a known neurotoxin and can cause mental retardation and all sorts of behavioral issues. It also can cause kidney damage, digestive problems, and it has been known to cause cancer in animals. So this is not a good thing. Environmentally, it can contaminate soils and crops, and certainly harm wildlife as well. Finally, the sixth criterion air pollutant is what we call particulate matter. This is suspended solid material that usually comes from dust, sand, ash, soot, smoke, pollen, or exhaust. Some of it is very fine or ultra fine, and when it's that small, it has the ability to penetrate our lungs' defenses and cause significant lung damage, bronchitis, asthma, and nose and throat irritation as well. So this is the list of our major 6 criterion air pollutants. We're going to pause here for now and continue our analysis and specifically look at acid deposition, sort of a secondary pollutant that can also wreak havoc on ecosystems as well as human health. So we're stopping there for now, and we'll see you guys in a little bit.